Hello everyone. In this video, I'll be showing you how you can use the color command in PyMOL. I'll be explaining the command and how it works. After that, I'll be showing you some of the examples. So we'll start with the specific command, and using this particular command, which is basically start from a simple keyword, which is color. It will color your atoms, because we all know that proteins have atoms, residues. Residues means the amino acids, right? The amino acids that are present in proteins. You can color the chains also. You can also color the entire molecule. And as we know in PyMOL, we do that quite a lot because we need to show different regions and we need to highlight those regions. That's why we use the color command. In the previous video that I made, I have shown how to use the show command and how we can show different structures. In this one, I'll be showing you the color command, right? Okay, this is the command syntax right over here. The composition of the syntax is very simple. You can see it start with the part 1, which is the color keyword. After that, we will be adding the code or the name of the color, like you can add red, green, blue, cyan. And after that, you have to provide the selection. That's the third component. In this selection, if you are not giving anything, that means it's automatically going to select the entire molecule. So you can provide selection for, let's say, atoms. Let me write it down, atom. You can also provide residue, and you can also provide chains information, right? Chain A, chain B, residue number, atom number you can provide, and it's going to color. It's really important because when it comes to bioinformatics, especially protein bioinformatics, you need to highlight different regions, and you don't want to specifically go to the sequence and manually do that. But it becomes really handy when you know how to use the command, right? So in this tutorial, what I'll be doing is I'm going to fetch one protein structure. So this is the command to get the structure. So let me write it down, get the structure, right? Okay, next, let me show you that this is the entire command, and as you can see over here, color name is right over here. In between color and the selection, we need to add either you can add red, green, blue, cyan, whatever color you want to add, and then part of the molecule you can add right over here, and it can be default for all the molecules. If you are not adding anything, that means it's going to consider the entire molecule. Next is, this is one of the example. If you want to color this particular structure, as we all know, this is the PDB ID, right? This is the PDB ID, and this basically is a particular protein structure, and we're going to play around with this particular structure, and we're going to color it red, right? So that's the color, and this is the keyword that PyMOL will understand. So it becomes the command is going to give you red colored entire protein structure, including all the ligand molecule. If ligand molecule is there inside, it's also going to get colored like this. So it will be red in color, right? Next is if you want to make it yellow. So as you can see over here, we are creating this in yellow color, right? And again, this is something that PyMOL will understand, and this is yellow. This is the color. What is next? As you can see right over here, we are not giving entire protein. This is specifically the ligand. And I'll show you where the name is written, how you can identify which ligand molecule we have to actually select. And here, residue that we are selecting is ligand. The same way you can select atoms, you can select residues, you can select amino acids, and so on, right? So this is how this construction of this command works. Next is if you want to select the chain. Look at this. Now we are selecting chain. Either you can do B, you can do C. It depends on how many chains your protein is going to have. So protein basically are global molecule like this, but they can also have multiple chains like this, and you can highlight all these chains with different colors like that, right? We do that in bioinformatics all the time, and it's going to this is the color, right? And that's something PyMOL will understand. That is for PyMOL, and we have to add that particular color. And there are some color options right over here. I'm just giving you some of the default color options. You can use red, green, blue, yellow, cyan, magenta, spectrum, and also if you basically want to color the atom by elements, setting the carbon color, all those things you can do by using these specific commands. And I'll show you how to actually apply them. Okay, now let's go to the PyMOL and then apply these commands and see what kind of output we are going to get. Before that, let me show you the resource that I've created, and I show that all the time in my videos. This is the website that I've created. It's called researchgold.com. In this one, what I've done is I built different courses And you can, if you go to researchgold.com and you will be finding this is the home page, and you can click right over here to explore courses, or you can scroll down and find out our popular courses. Right over here you can see virtual screening in drug discovery. If you want to identify novel molecules and you want to do virtual screening of thousands of millions of compounds, this is the course. For that you need to be a little bit expert in case of how to use commands. So these kind of videos that I'm making on YouTube are going to help you how to understand different commands, right? And there are so many other courses right over here. The course that is specifically for this particular the course that is specifically for these kind of skills like color, show, or any kind of PyMOL based skills are these two courses. One is protein molecular visualization. This is going to help you visualize protein in a different way. I'm just showing you color, right? That's a very small part of this particular course. And then you want to edit the protein structure and using a lot of different commands. This is the course for you. So these two courses are specifically designed for you to make understand the PyMOL better and how to efficiently use the PyMOL. After that, one of our most popular course that is right over here, molecular docking. And after that, you should do the molecular docking. And I'm in the process of creating molecular dynamic simulation because I'm getting a lot of requests for that. All right. Thank you so much for watching this particular resource. Please click and complete these courses. You will also get a certificate, something like that, if you complete the course. And then that certificate, you can use that certificate in your CV. You can highlight the skill set because in the certificate you can see right over here we have shown what are the skills that you have understood. So I have also I'm also providing the mentorship support. So if you can click on contact us, you can get my details right over here, and you just message me or you can email me. I'll try to answer your queries. All right, with that note, let's move on to the PyMOL and understand how these commands they're gonna work. Okay, I'm here in my PyMOL window. I've opened the software, and now we will be adding commands. For your reference, what I've done is I've created a detailed markdown file where I have all the commands and their basic functions. Right over here, you can actually see it's a detailed the file that contains all the command. If you need that file, just send me an email, or you can basically contact me via WhatsApp, and I'll try to provide you that particular file so that you can play around and add your own specific commands that you're using. Okay, we'll start by getting the structure, and we all know that fetch command is the command. I'm not going to type just to save time. The first one is fetch and the protein structure PDB ID, and after that you press enter and immediately you're going to get the structure. There is no need for you to go to PDB, download the file, although it's recommended because you will be exploring what kind of structure you want to actually see. So look at these red dots, they are water molecules, and then you have a protein. Everything is done green. You don't want that, right? You don't want that. Now, if you want to color everything in red, so basically what we do is color space red, and everything is going to become red. Look at that, right? And if you want to do color space cyan, everything is going to become cyan, and this is the coloration, right, that you're going to get. Or what you can use is color space red, and then as I told you that you need to provide selection after comma, and then all means everything. So now its entire thing is going to become red, right? So as you can see, if you want to select a specific object, let's say ligand molecule. Now you will be asking, sir, from where we'll find out the information about the ligand or the name of the ligand. So let me zoom in, and you can see there is a structure. Because of the red coloration, you can't actually differentiate this from these lines. It becomes really difficult. So it is recommended that you color the ligand molecules in a different colors. For that, if you know the name of the ligand, in my case I know the name of the ligand, so I can just simply run the command. If you don't, then what you can do is you can click on right over here, go to the right side bottom panel. There is a small box, and S is written. Letter S is written. You click on letter S, you will see the sequence. S means sequence. Now you can go like this, and you will identify there is one ligand molecule, MK1 is there, and immediately after, once I clicked on that, it got highlighted, right? So that means MK1 is the name of this ligand. So I know the name of the ligand. Now I can basically color this, and for that one I'll be selecting the yellow color. So I'll paste the command right over here from my markdown file, and the command is color space yellow, comma, after comma, then again space. You have to provide the specific ligand name, which is MK1, but before that you need to write RESN. Once you have that all set, just press the enter button and immediately your ligand molecule is going to become yellow. Look at that. Wonderful, right? Now it's so clear that you can clearly see this particular molecule highlighted in the center, and there is no need for you to do anything at all, right? Next is this protein. I know that it has 2 chains, so I'll be selecting different chains. So right over here, I'm coloring chain A with cyan. So one chain immediately you'll see got colored in different color. Look at that, right? It's a dimeric protein interacting together, and the ligand molecule is in the center. Wonderful protein. Looks really nice. Next is you can also color the second chain. Right now it's in red. I'm going to color it in green. So color space green, comma, chain B. Enter, and you can actually see it got color differently. Now, one thing you will observe that this ligand is the part of the chain B. So if you want to make it again yellow, so you have to go back and run that command again, and it will be colored in yellow. So this is how you can play around and do this bioinformatics art and color different molecules. It's really satisfying, I must say that. Next is if you want to color different residues, right? So for that one, let me type it down. So I want to color, and then I need to provide color, which is in this case, let's do magenta, and then comma. After that, resi, RESI. Remember, in that one, we have written something else, which is RESN. In case of residues, you need to type RESI space. Then let's say 45 is the number that I want to color. If I press enter, immediately you'll see that 45 number in both of these chains got magenta color. Look at that, right? If you want to highlight these kind of regions in the protein, right over here, look at that. So you can highlight specific residues. Now this was the number, and let's say I want to highlight histidine residue. So what I'll do, I'll keep everything same. Color, I'm selecting orange right over here, then comma, RESN, then histidine, HES. That's the code for that particular amino acid. Now let's zoom out and then run this command. So histidine is going to get right over here, because both of these chains, they are same, right? And you can clearly see that orange color histidine is being colored. So you can locate different residues by using the color commands also. You don't have to go to the sequence. You just type that, and you immediately that particular amino acid will be highlighted. So look, so it will be really good, right? Now, if you want to color the solvents, so for the water molecules, right over here, you can actually see some of the water molecules, they are green, some of the water molecules, they are cyan. So I'm going to change them. The solvent, I want to make blue. Look at that. Every solvent molecule, it became blue in color, right? So the command for that one, let me show you. It's also highlighted right over here, which is color space marine, which is the different color, comma, solvent. So you don't have to do anything. You can also type RESN space HOH. That will also do the same, right? Next is, now you are happy with everything and you can save this structure, but you want to again play around and you want to revert back this particular to the parent coloration, right, that we started. So this is the command that you will be running, which is util.cbc. This is going to revert everything back, initially where we started this. So automatically assigns a different color to the chain, right? So it's going to assign different color to the chain. If you have multiple chain, you don't know what to do. It's not going to automatically go back to the first one, but it's going to automatically default assign different color to each chain. So you can actually use this one. There were some other commands that we also use. Let's use that using the keyword, which is util.cbag that we have already, if you do that, this is going to color by the atom, some of the default command, and then I think cb we have already run. Let's do it again, right? So as you can see, it's going to color atoms by the carbon color. So you can actually play around with these util commands also, and then see which one is helping you out, identify the best one. All right. So please contact me if you have any doubt. Check out the Research Gold website for upskilling yourself on bioinformatics, especially when it comes to protein bioinformatics. Do not miss the opportunity, because the course price is not really not very much. It's very low and everyone can afford this, but it's going to give you a lot of skill sets, and you can do actual research projects by understanding those skill sets. There are multiple courses that I've created. That's why I call this website research goal. It is going to help you achieve the goals that you have assigned in the area of research. All right, everyone, we'll meet in the next one. Take care.